Thank you all for coming here to our fourth London Airflow meetup. And I'm Kaxil Naik. For those of you who don't know me, I'm the organizer of this meetup, the PMC member and committer to the Airflow project, and from last few months, senior data engineer at Astronomer. Big thank you to Nathan for helping to organize this meetup at King. And I will hand over it to Ash, who is our first speaker. We have 3 interesting talks coming this way. And yeah, please, pizzas are for you, but just wait for the talks to finish.
Hey, right. I'll try and keep this relatively short and sweet so we can get on to the more interesting ones. So yeah, I'm Ash. I'm on the Airflow PMC, and along with Kaxil, we do most of the releases, or all of the releases for the 110 series. So yeah, just going to kind of give you a quick rundown into what's new in the last 2 releases, 0.4 and 0.5. They were both released in September, August. And then kind of give you a sneak peek into what we think we're going to add into Airflow 2.0. Click on no work. Okay. So the first thing, hugely exciting, is we've changed the logo so it doesn't suck. It's all nice and vector, and there we go. Not very big, but it's nice and modern and no more jaggies and stuff. Anyway, we changed the logo. So yeah, 110.4 released at the start of August. Summary, lots of commits, lots of fixes. Some of the more interesting ones, you can now add customized links in your operators. So these row of buttons down here, the Amazon, Google, Facebook, Netflix, you can add a bit of code into your custom operators and then make that link somewhere. So an example of where you might want that is you could link to your Spark logs directly from the Airflow task overview without having to dig in, get the URL, copy it, and find it manually. It's a little bit fiddly to have to add it yourself. We don't have that built into any of the stock Airflow operators. But if you have if you know how it works in your environment, you can add them. So yeah, that'd be good for Spark jobs, EMR, GCP, that kind of stuff. If you use Kubernetes at all, you can now add. You have much more control over what pods get launched by Airflow. You can define a pod mutation hook in your settings file, and that gets passed a pod object. You can change whatever you like about that, and just before it gets launched, you can add labels, you can change quotas, you can set up things. So yeah, you have control. If you want to do this, look in the docs, or possibly just Google for that, grep for that string in the code base. Probably not very well documented. If you use AWS RDS, you can now do Postgres and MySQL via the IAM thing rather than having to hard code a username and password. You can use AWS IAM auth to get a temporary credential for 5 minutes, which is quite nice. Then that brings us on to 110.5, which was released the end of August, and this was mostly some critical bug fixes that happened about 110.4. So we had yet more version pain. Kombu and Celery released a new version, and it broke on Python 2, so we had to pin that down. I managed to completely mess up backporting some features and broke the data proc operators. And there was some bug around trigger rules. Some other interesting features we added. Oh yeah, if you're not already aware, please migrate away from Python 2. Airflow 2.0 will not support Python 2. Python 2 is end of life as of January the 1st. So unless you happen to be paying Red Hat for support, don't be running Python 2. Even if you are, please don't run Python 2. It makes my life hell. The reason I messed up the backport was because of Python 2. Other things we added in 110.5, default timeouts on Kubernetes, speaking to the Kubernetes API, rather than just hanging forever. we added a default timeout of 60 seconds. So if you don't get any response back in 60 seconds, it will time out and retry, which apparently helps on Azure if you're unfortunate enough to having to run EKS. So that's kind of a brief overview of 1.10.4, 1.10.5, mostly kind of small things and bug fixes, but a few things. And now the more interesting bit is Airflow 2.0, which we're gonna add some logger and temporary hack stuff. Things that we've already started: dropping Python 2 support. Master branch of Airflow will not run on Python 2, so that's kind of already there. There's a little bit of tidy up left. We've rearranged all the CLI commands, so rather than Airflow list _ dags and Airflow initdb, it will be Airflow dags list, Airflow dags clear. So everything's like Airflow dags and then the commands underneath that. If you've used the CLI, you'll have to retrain your fingers. We've kind of got rid of contrib from all the operators and stuff, so there's a whole load of things that have been moved around and shuffled, so it's all a bit more sensible. Those aren't the interesting ones, though. These are the ones. So 6 things. Go into more detail on each of them. Knative is Kubernetes native function as a service kind of thing. What we're trying to do with the Knative executor is give you the balance of control and isolation for the Kubernetes, but without having to pay the pod spin up time for shorter running pods. Because if you're using the Kubernetes executor, the spin up time to start the pod can start to get significant if your tasks are relatively short. Knative tries to kind of balance the power of Kubernetes with the having to pay the startup cost of the salary worker, for instance. Daniel Imberman, another one of the committers and fellow employee at Astronomer, gave a talk about that at the Seattle Meetup last Thursday, recording for which should be available soon. If you want to find more about that, watch the talk. We'll send a link around to our recording and here's when they're available. Improving the speed of the web server. So right now, if you have a large number of DAGs, your web server may not ever start up. We've got some people who've got 1,000 DAGs, and you have to change the worker timeout to like 10 minutes because it slowly, sequentially, it's creaking at the seams. So we've started on that. Myself, Kaxil, and someone from Google in Seattle, I think, have started working on changing how the web server deals with DAGs. Do not have to go to files on disk at all and to read it from the database. But to start with, that's just focusing on the web server, making that more performant and startup time. But once we do that, it kind of gives us some extra things to change how the scheduler works to fix that. The slide says it all. It should be auto updating. This is 2019, for goodness sake. We'll do that. We may also give the UI a bit of a revamp and play some, give some thought to UX and design and stuff like that. But yeah, the big one we want is you should just be able to see the tasks sort of update and look at that, and doesn't that make Airflow that much nicer rather than refresh? Oh, it's done. Oh, there we go. But yeah, scheduler performance. I'm sure we've all seen this. Like, why is it taking so long? It's doing nothing. And then it sits there and it sits there and it sits there, and then it suddenly kicks them off. I want to fix this. Going to work on the scheduler, get it behaving, both slightly better diagnostics about what it's doing and why it might not be scheduling, and also reducing the lag of scheduling. Because like an empty scheduler with one DAG still kind of takes too long. So going to fix that. Anything the UI can do. Sorry, quite proud of that one. We need an API. We've got one, it's experimental, that doesn't count. Airflow needs an API. We're going to start working on this. Anything the CLI does, anything the UI does is going to be exposed over a first-class API. And it's going to actually work and be documented. And then the final thing is production-ready Docker image. So we've now got Dockerized CI, thanks to Jarek. Most people, if you run Docker in production, they either take that and hack it around, or they use Pukel's Docker container. It's great, it's what I did, but we should have something under the Apache name. So we'll do that. We'll have a nice Helm chart. There's one already, which I think was an old fork of Astronomer's Helm chart that someone donated to the community, but there'll be a maintained Docker image and a maintained Helm chart so that if that is how you run, it will be easy and official. That's it. Those are the 6 items kind of that we want to focus on for Airflow 2.0. Any questions about any of that? Good. Well, I'd like to see. In which case, I will very quickly hand you over to Nathan and Nick, who are here from King, and they're going to talk about how they use Airflow, I guess.
All right. Hello, everyone, and thanks very much for coming out this evening. Yeah, we're really pleased to welcome you all and to the 4th London Airflow Meetup. Great to see you all in so many numbers, and please stick around towards the end for a few more drinks. We'll have some food as well, and we'd love to chat to some of you. So just to get going, this is basically what we're talking about today. You can decide amongst yourselves who's who out of these 3 here. I mean, the topic is somewhat trite, but basically, I mean, at King we use Airflow unsurprisingly, but we have many teams who use it, and in different ways with different installations, and these teams have different needs, different requirements, and as a result, some of their experiences of using Airflow are different as well. So what we want to try and do today was try and touch on some of those points. Quick introductions. My name is Nathan. I'm a principal data engineer in what's called the Core Data Products team.
And tonight you get 2 engineers for the price of 1. So I'm Nick, and I am the manager for the event management team in King.
And so and these 2 teams kind of form part of a larger shared tech org at King, which deals with all things tech that's shared. Cool. So a quick couple of things. This is a rough schedule of what we're going to go through, just a little bit about King and some other topics. So who is King? Well, if you've been near a smartphone anywhere in the last 7 years or so, you may well have played one of our games. This is what we do. We make free-to-play mobile games. Candy Crush being the most obvious example here, the most popular one by some distance. But we have lots of other franchises as well. Some quick facts about King. King's like a world-leading interactive mobile entertainment company. Been around since 2003, which is perhaps longer than most people know us. We released Candy Crush back in on iOS back in 2012, but been around since 2003. Such was the success of that game, we ended up having a public IPO on the New York Stock Exchange back in 2014, and then got ultimately acquired by Activision Blizzard in early 2016 for a princely sum there. And over about the last 16 years, we've developed over 200 games, and to this date have about 260 million monthly active users. And still to this day, Candy Crush is still one of the top grossing games in many markets around the world, which is a real testament to the developers and the team managing that game, that they can keep it so high up those charts in what's a particularly fickle industry.
So a bit more about the teams we work in. So I manage the event management team. King Games produce around about 100 billion tracking events every day. Our team is responsible for processing these and getting them into BigQuery. This really is our lowest grain data. It's used by other teams such as Nathan's team, by data scientists. We use it for operational monitoring, incident management, and so on. A few key stats. So as I mentioned, we process 100 billion tracking events each day. This means we're processing at roughly a rate of 1 million events per second, but we do have spikes where we're getting data coming at around 4 million events per second. We have 4,000 different tracking events that a game can use. So this equates to 4,000 tables in BigQuery we have to populate each day. And just the raw event data alone equates to around about 15 petabytes in storage in GCP. So our Google account manager is quite happy with us. And here is a little very high-level architecture diagram of how we ingest data at King. Just to go through the main flow, so we have thousands of game servers running in a dedicated data center in Stockholm. Every hour, these produce log files that get pushed into GCS. We then use Cloud Dataflow to process these and populate a number of data sets in BigQuery. And we're also seeing more and more drive to having real-time data available in King. So all game events also get published to an on-premise Kafka cluster, which gets mirrored into PubSub.
So that's kind of roughly what Nick's team does. From my perspective, so we build on the great work that these guys do.
Excellent work.
Excellent work. Apologies. And we basically use that data to provide like summarized, aggregated, clean data sets that take that raw event data, image data, and other third-party sources, and use it to build things like high-level KPI emails, dashboards, and we build tables in BigQuery as well, which will facilitate reporting around things like in-app purchases, where we acquire our customers from, how engaged are our players, how successful our in-game advertising is, and also do some stuff on competitor analysis. Typically, these things are used by quite a wide range of people at King, from high-level executives who wanted to see how things are performing from one day to the next. Data scientists, we have teams of data scientists aligned with a game who their responsibility is just focusing on improving that game, and different product managers in marketing, advertising, who want to see how their things are doing, and also the data also feeds other applications within King as well. And other data engineering teams also take advantage of the output that we produce. And this data is primarily for the purposes of more traditional historical analysis. We use it for game optimization, trying to make our games more fun, more engaging, and hopefully making them monetize better. Hopefully people will give us some money for the pleasure of playing our games. Types of predictive modeling, and also used for the general purposes of like game operations. That's broadly what we do.
Yeah, so now we'll do a brief history of data engineering at King. We wanted to talk about 2018. So 2018 was a really significant year for King. We took the decision to migrate all of our data infrastructure to GCP. This was probably the biggest change we had in King in terms of data processing since 2011, when we started using Hadoop. This was a full-on migration. We managed to complete it in 12 months. So start of 2019, we went in with all of our data processing, so thousands of Hive and MapReduce jobs having been migrated.
Yeah, I guess as well as doing that, it kind of presented an opportunity as well for us to really start reevaluating other aspects of the work that we're doing, and primarily the data operations that we do. So up until midway last year, these were the kind of things that we were using to do our data operations, right? So we were abusing this poor guy here, abusing Jenkins to basically run shell scripts, right? That would probably run SQL statements for Hive or BigQuery. Maybe we have a bit of Python in there as well, and some of it would be kind of in Dockerized applications. But I think we started to realize that the cracks were starting to show here, and we needed to change, and that was kind of like where Airflow kind of comes into the mix. So let's talk briefly about kind of moving to Airflow. So from my team's perspective, when we kind of like look at the characteristics of the data pipelines that we produce, what do they basically consist of? Well, we roughly have about kind of 50 data pipelines running, and typically they're running on a very, very traditional batch cycle every day in the early hours of the morning, and they're sourcing from, well, these days now GCS and BigQuery, as I said, picking up where Nick's excellent work hands off. but also pulling in data from third-party sources as well, so from the platforms that our games run on and various other things as well. And our outputs are, again, GCS and BigQuery data sets. But the pipelines that we produce also have their own, have to have interactions with services that we also run within King. So obviously things like GitHub for the code, Vault for storing secrets, Artifactory for where we store our private Python packages, Looker for for dashboards and such like, PagerDuty for out of hours support, i.e. getting woken up in the middle of the night when things go wrong, and obviously King has, as I said, has its own applications that our data pipelines need to interact with. So when we decided we wanted to move to Airflow, what were some of the goals that we wanted to get out of that? Well, primarily we wanted to become a Python orientated team. As you saw previously, it was a mixture of different things, and I think for obvious reasons, kind of moving to Python has lots of advantages. And we really wanted to needed to simplify and consolidate all of our code. What ended up happening was that basically every pipeline that we built was its own GitHub repo, and that made things become increasingly hard to navigate, develop, and test. It resulted in lots of code duplication all over the place. There was inconsistent styles, and it just really needed to change. And we wanted to, hopefully by doing this, kind of improve a lot of the robustness, efficiency, and accuracy of all of our processes. These pipelines were mostly constructed with these large monolithic bash scripts, right? And we needed to break those up into smaller, discrete, atomic tasks. We also wanted to be able to provide new opportunities for team members. When we're kind of running these operations, it's the same things kind of running over day after day. Some of that stuff can get a little bit boring, and so we need to kind of freshen things up, give people new opportunities, new tools and technologies to get familiar with. And we also want to kind of grow King's reputation as well, primarily by hopefully being part of and contributing to an open source project, Airflow in this case. We're not there yet, we're still very much users, but I hope in the coming months and years, hopefully, that will change. So with all that in mind, then we had some kind of decisions to make really about kind of what kind of Airflow to use. It basically boiled down to two decisions, right? Do we want to use just the core project and build our own managed installation of it, or do we want to use some managed service, which in this case would have been Cloud Composer? Now, maybe there's a question in the room. Why not that? Well, I suppose this was like mid 2018, and I guess to be honest, we didn't really know that much about astronomy at that point. But I guess in a more correct answer is that I suppose we were trying to get some kind of POC kind of up and running in the shortest time possible. So already having those kind of financial relationships with Google already sorted out was probably easier than starting to enter that stuff. So no offense. So what do we need to do? We needed to take all of our non-SQL code, right, and basically rewrite that from Bash into Python. We knew we would need to develop some kind of custom operators. As you saw, we have these internal services that our DAGs would need to rely upon. We had built some Python packages to facilitate that, so we probably want to wrap those in custom operators. Unfortunately, when we were looking at Cloud Composer around about mid last year, when I think Cloud Composer wasn't even GA, there was this ability to install your own Python packages from private repositories wasn't available. It just wasn't there. Google did provide some workarounds to it. They were kind of unsatisfactory at that point in time. I'll note that feature has been added since May 2019. I've not tried it out. If anyone has and they've got experiences of that, I'd be keen to hear what you have to say. This is my own personal experience was that I found that developing and testing in Cloud Composer was a fairly slow kind of experience. That may have changed. I haven't looked at it for a little while. But more correctly, and this is more a King thing rather than anything to do with Cloud Composer or Airflow itself, our own internal firewall restrictions between Google Cloud and our internal services essentially prevented us from being able to directly talk to these services, which kind of ruled it out. And that's still a problem today to a certain extent. So basically, what did that mean? It meant that we decided to build our own installation of Airflow off of the core project. We're just going to use open on-prem VMs, put it all inside Docker, use the Puckle repositories as a way of getting a kickstart there, and it's only running like single node kind of local executor at this point in time. We started re-engineering all these pipelines, I guess around about the start of the year, and probably be complete by the end of December, hopefully sooner. On the way, we've had to develop several plugins, and so this is maybe where we can start thinking about potentially making that transition from being just users to contributors. There's maybe some possible candidates. So we bought some plugins for things like Looker and PagerDuty, Vault, and Stackdriver as well. If anyone else has any kind of experiences of adapting Airflow for some of these applications, again, I'd be keen to hear what you have to say. And this is just a very quick illustration of like what one of our DAGs might look like, right? Parallel processes here. We've got BigQuery operators here, some custom operators that we've built as well. So just of one.
So the event management team is quite different to the team that Nathan manages. So we're less a traditional ETL team doing overnight jobs. We have stuff running pretty much all the time, so loads of micro batches being kicked off throughout the day. So I've got some quite abstract photos, but hopefully they'll make sense. So this is representing loads of mini jobs running throughout the day. All of our tasks are fairly coarse-grained, so typically we work around building a container that contains all of the on-premise dependencies we rely on. Our software lifecycle is all geared around building that container and testing it, which is quite a different approach to what Nathan's team's doing. In terms of testing, we're less worried about how we test the workflow tool itself. We're geared all around just testing the container, and often our stuff is smoking, burning, and on fire, just like this picture. Would anyone like to guess where this photo is taken from? So this is Stockholm at midnight, and this is important for us because we change our execution date at midnight Europe Stockholm time. Europe Stockholm may be UTC +1 or UTC +2, depending on if we're in daylight saving time, and that's just something we have to think about and manage. And then I think compared to most other teams in King, our team manages many more workflow environments than the other teams. So this means things like being able to spin up new environments quickly is quite key to our team. So Nathan mentioned before, in King, we were basically using Jenkins to schedule and automate all of our data processing jobs. That was the same in the event management team. So we were using Jenkins on-prem to run all of our stuff. So we wanted to start to think about moving away from Jenkins on-prem. The reason, or the things we were trying to solve, our team, we wanted to spend less time worrying about managing workflow systems. The value add we bring King is all around the best way to track things in games, how to process that information. We're not trying to sell ourselves as a workflow team. Our team is fairly cloud native, so pretty much everything else we do runs in the cloud, and it was only the scheduling aspect that was still on-prem. So this has issues such as we were having to call people to go to our Stockholm data center to change disks on our Jenkins server and so on. And our team manages more environments than the others, and we've got a lot of new work in the pipeline where we'll have even more. So this need to be able to quickly, easily spin up new environments was really key. So in our team, we evaluated several options. So the most obvious for us was, well, let's just run Jenkins in GCP or on GC or something like that. We were comparing this with running Airflow on GCE or GKE. And then we also evaluated Composer. So we were doing this early 2019, which I think Composer would come on a bit of the way compared to when Nathan started looking. And the winner for us was, drumroll, so Cloud Composer. So we selected it because it seemed to match our requirements well, so we could start to spin up new environments really quickly. It meant we had more stuff running in the cloud. It was a fully managed service, so we could just concentrate on the data processing, tracking stuff that really interests our team. We started our migration in Q1 2019, and we actually completed in about 1 month. But I should caveat that to say our DAGs are really simple. We have really very few tasks in our DAGs. They're all coarse-grained. And all of our Jenkins jobs were launching Docker containers. And it was really easy for us to migrate these just to use the Kubernetes pod operator. So we saw an example of a typical DAG from Nathan's team earlier. This is probably one of our complex ones. So this is for a application code named Graffido. We have to have a few steps at the beginning, sorting out that nasty time zone stuff. And then the bulk of the work is done just in a few tasks, kicking off some entry point in a container that will then go and do lots of things. And so I was trying to find a way to get a spinning Airflow logo in somewhere, but
All right, so yeah, so that was basically kind of get into Airflow. So like, what's life been like whilst we've been there? So I guess from my team's perspective, what's been good about it? Well, now we actually use an application for what it was intended. I mean, silly thing to say, but yeah, as good as Jenkins was, that's not what it was designed for. So, and this is obvious if you're familiar with Docker, but yeah, running Airflow inside Docker gives the ability for everyone to have their own locally running production-like development environment, right? Which is great to have that confidence that the thing that you're developing and testing on, by the time it gets to production, is probably more or less going to work exactly in the same fashion. Again, you know, breaking out all of these big bash scripts into these smaller tasks really helps to improve the overall efficiency and reproducibility and recoverability of our DAGs. And by bringing it all into Python, it's massively improved our overall kind of quality of code and consistency across all these different pipelines. And of course, using the core project gives us access to some of these great new features nice and sooner. However, of course, being close to that bleeding edge has some occasionally undesirable consequences. DCS hooks, anyone?
Data proc operators.
From our perspective, in my team, how we run Airflow, running on a single node is not great for scalability. My experience has been that kind of Airflow scales up, pretty well before we kind of really need to scale out, but we'll need to get there at some point soon. From an ugly perspective, so this is something that I struggle with a little bit. Is we have DAGs which trigger lots of other DAGs, and so being able to visually see those dependencies across DAGs is something which I find a bit tricky to do at the moment. And I guess following on from that, kind of having kind of DAG level statistics or charts kind of in the UI would kind of certainly aid us in some aspects. It's great having that fine detail at the task level, but also viewing things at DAG level is beneficial as well. Again, this is something that we do sometimes. We might have DAGs which don't run on schedules, but we might need to trigger them at periodic intervals with some kind of custom argument for them. I know you can do that from the CLI, but from the UI would be great as well. And I think you mentioned this, task scheduling lag. Just as a quick example, so this is one Gantt chart from one run. This thing only lasts 2 minutes, and we've got this task here, which ran for 4 seconds, ended at 15:36:33. This next task here again, ran for 4 seconds, but only started 15 seconds later. So most of this time here, most of this 2 minutes is spent just waiting for tasks to be rescheduled, which in the scope of a 2-minute DAG, okay, doesn't add that much, but all these things start to add up with lots of big DAGs with lots of tasks. It really does start to make a difference. So, great.
So then the good, bad, and ugly for our team. So remember, we chose Composer and to stick with a approach of having really coarse-grained tasks, a few of them. So now we can quickly spin up new environments. Composer integrates well with other GCP things we're using, such as IAMs, Stackdriver, and so on. It is a fully managed service. More on that soon. We don't have any scheduling lag, or hardly any, because we have hardly any tasks. We can, so obviously Composer is not running on the latest version of Airflow, and we hope that they've done quite a bit of testing on the version they pick, so probably things like data proc operator being broken wouldn't sneak in to Composer. I mean, this is obviously subjective, but those who haven't used Composer, when you create a Composer environment, you have a minimum of 3 nodes. So if you have an environment that's not really heavily used, maybe it's for some testing purposes, or in our case, maybe for a small game, this may work out quite expensive. And so even a minimal 3-node cluster, you're looking at around about $400 a month. That's true even if you had one DAG that ran once a month that ran for 10 seconds. We touched on this earlier, but we have these, I don't think they're strange time zone requirements, but we don't run everything on a fixed time on UTC. So we feel sometimes the most complex part of our DAGs is all around handling these time zone aspects. Composer itself, upgrading environments has been quite flaky, which is fine. Support will often tell us, don't worry, just delete your environment, recreate it. Sure, no problems, quite quick. But unfortunately, then you lose all your DAG history. So if you like to use the charts from the Airflow UI to see how job runs have changed over time, that's gone. And then the ugly. So the ugly for me is things that are worse than the bad. I'm not sure if Nathan had the same definition. But we've had a lot of Kubernetes pod operator production issues. Typically, the problem will be Airflow's launched a pod. Somehow, it's become disconnected. Airflow's launched another pod. We've now got many pods running. So we have to handle in our code the fact this may happen. So some of our things shouldn't be running in parallel for the same parameters. And we need to have logs and so on to handle this. And confused GCP support. So by this, I mean, sometimes we'll have an issue. We speak to Google support. If it's a pure Airflow issue, they've got a tendency to push back and say, we don't really want to help. But personally, I feel they like to use Airflow to generate revenue for the company when it's working well. I'd like to see them taking a little bit more ownership for Airflow issues and maybe contributing back more on that.
Right, yeah, so just briefly, just to touch on this, so me and Nick have been talking about kind of Airflow amongst our teams, but as I mentioned, we're not the only data engineering teams here at King, and we're not the only teams using Airflow. In fact, then there's other teams that are also not using Airflow as well. But when we do look at all of the Airflow usage in King, what does it look like? Well, from a Cloud Composer perspective, we've basically got like 3 teams using it at the moment. Nick's team here, they're running like eight different environments at the moment. A team called Flame, they're running 3 Airflow Cloud Composer environments, and a marketing data science team, they're also running another Cloud Composer environment as well. When it comes to Airflow running off of the core project, there's my team here where we're running 4 different environments, and then another team out in Barcelona also running, I think 3. So this has its own kind of like sets of good, bad, and problematic issues. I mean, just briefly, I suppose this kind of like setup gives teams a lot of independence and a lot of, I find that data engineering teams or engineering teams in general want to kind of own the universe they live in, right, and not have too many external dependencies. And that's great for speed and the velocity of those teams and their ability to deliver new things. But I suppose the problem with this is like code doesn't really get shared. Like if we build a plugin over here to interact with, I don't know, PagerDuty, for example, then maybe the Flame team over here is also re-engineering that a similar operator for their use case. So that could be a bad or good depending on your views on that. But it's certainly something that exists. And I think Nick was talking about cost. He was talking about one environment, $400 a month. Now we've got what, 12, and now that's you do the math. You start to maybe question the value of that perhaps. Right. So that's kind of like our journey up to about now, I guess. So what's next for us? So basically, where are we going? I mentioned this a couple of times. Progress from being users to be contributors. I'm hoping that's something we can start doing next quarter, leading into next year. See how that goes. As I mentioned, our setup's just using single node local executor. It's probably going to need to scale out soon. So looking at the Kubernetes executor in a bit more detail is probably going to be necessary there. Whether that's running on our own in-house on-prem Kubernetes cluster or in GKE, I don't know, but that's something we need to spend more time on. Yeah.
And within King, we're getting more and more demands for real-time data. So we envisage having far more streaming jobs in the future. Obviously, Airflow is more geared around kind of batch jobs. It'll be nice to, I don't know, maybe catch up with you afterwards if anyone's doing any streaming work with Airflow, see how that could work out. So we need to start getting some ideas for that. How the execution date will change. Do we restart streaming processes or have them running for many days? Stuff like this.
Out there, and I guess finally, what would we like? So it's about becoming contributors. Maybe some of the things that we end up doing. This is more a kind of a quick pulling things out of the air type.
Like the team planning. Now we assign JIRAs.
Yeah.
That
More dynamic UI. You mentioned it already.
Done.
So done already. Tick.
Yeah. Hopefully this is self-explanatory, but so there is some time zone support currently. So you can when you create a DAG, you can specify the time it should run with a time zone. But this creates a fixed time with a fixed UTC offset. And we would like something that would help companies like King, where we operate in time zones with daylight saving.
Don't ask why. I mentioned this earlier on, but the ability to be able to visualize dependencies across. Great.
Time zones or cross-DAG?
Okay. Brilliant.
Nathan calls this one the daggity do. Yeah, so sometimes we have a DAG where we have a task which is doing some sort of check on the success of previous tasks. So we may be, we run a data flow job, and then when that's complete, we may have some sort of check to make sure we haven't introduced duplicates into BigQuery. It would be nice if the check fails, we could somehow, rather than just rerun that task, actually say we need to rerun the whole DAG now, or clear the whole DAG or something like that.
Yeah, I mentioned this earlier, just this ability to be able to trigger DAGs with arguments directly from the UI.
Yeah, so we have many DAGs which trigger other DAGs. And if the DAG being triggered has already run, and then the triggering DAG reruns, the task doing the triggering will fail. And it would be really neat if we could say things like, if the DAG to be triggered has already run, maybe skip, or maybe clear it and run it again, or maybe fail like it does currently.
Hold on, Cedric. Yeah, and finally, I think this ability to be able to backfill from the UI, and there's been maybe some problems around that, but that would be a neat little thing as well. I think, rather abruptly, that kind of brings us to the end of what we want to talk about. Again, thanks very much for coming. Thanks very much for listening. Please do stick around. We've got one more talk to come, but yeah, we'll be here and we'd love to chat with you.
And jobs.
Of course, it would be remiss if I didn't put that little link up on the wall. So please do check it out if you have any interest.
Come and work with bad, ugly people like us.
Yeah, and we've got a bit of time for any questions. Ooh, here's one.
Okay. So, sure. So the question is, in terms of our streaming pipelines, how many different source topics do we have? And how do we deal with schema revolution? Okay, this is a nice easy one. So we typically have a topic per title, and King has around about 200 titles. And we have some internal applications which we consider a title. So we will have 200 source topics. In terms of schema revolution, our tracking events are immutable, so they don't change. If somebody wants to change an event, they have to make a new version. We then have a secondary layer that we call internally event classes, which will bring those different versions together. It's typically some sort of view in BigQuery doing a union. And then we have another layer on top of that we call semantic classes, which is where we combine many different tracking events which may have the same semantic meaning. So maybe they all represent starting a game or installing a game.
Oh, one more.
Yes, sure. I mean, I can just, so the question was around our Kubernetes pod operator issues and if they were still ongoing. So a lot of these problems seem to relate to having an under-resourced cluster. So by having dedicated node pools and having a larger Kubernetes cluster for actually doing the workload, a lot of these issues went. I think what I would say is Composer is a fully managed service, but actually you need to have a reasonable amount of Kubernetes knowledge. It's quite difficult to understand when these issues are happening if you do have a resource utilization issue, and then you need to have quite a bit of Kubernetes knowledge to understand what the next steps to fix that would be. But that solved it for us for now. It sounds like something's coming.
All right. Any more? Oh, last one right in there.
So the games publish data into an on-premise Kafka cluster. These get synced to PubSub using Kafka Connect workers for some games. And then we will just be launching ad hoc streaming jobs. As we move to replace more and more of our batch workloads with streaming jobs, this is where we need to really start saying, how will we run these from Airflow? Is it even the right tool to be using?
Last chance.
Any bad ETL questions for Nathan?
All right. Thanks very much.
Thank you.
It's on the list. Hello, everyone. That's the last talk for today, so bear with me. The food and drinks are after that. Ash mentioned before that we have a new logo, and that's actually really cool contribution from Astronomer team. Astronomer does really great job on Airflow. This new logo is actually right now quite good because it has better colors. It matches much better with many different presentations and many different logos that you have on screen, including our company logo. And a few words about myself. I'll tell a little bit about the company that I'm working on. I'm a principal software engineer at Polidea. Polidea is a software house in Poland. So I came from Warsaw, from Poland. For half a year, almost now, I'm an Apache Airflow committer. I'm also certified GCP architect. I used to work at Google. Actually, I was a CTO of Polidea for 6 years, and I decided to not step down, to upgrade to an engineer back. So I'm a principal software engineer, and I have some fantastic people who are here as well, who are running the company. So there is a CEO of the company, Grzegorz. There is Karolina, who is a project manager in our team. And we have 2 engineers here, Kamil, who is the Apache Airflow committer as well, and second Kamil, who is the DevOps in our team. As an engineer, I have the fantastic opportunity to work with those great people, both at the management and as colleagues. And I'm also a choir member. I finished my choir career after 29 years recently, but I still sing. Good. A few words about Polidea. We have a team in Poland, in Warsaw. Everyone is in Warsaw, in one place, in one office. We have more than 70-ish number of people. We delivered a lot of projects, more than 100. The 3 million users of our apps, we have to put something like to match King. 3 million is not that big, but still. And we have, I think this number is outdated, 75%, maybe 80, 90% of our business is through referrals. So I think we do a good job. I hope so. We are on the market for 10 years now. And we traditionally started from mobile application, or we started when the mobile revolution started. So we developed mobile applications. That was our core expertise for iOS and Android. But right now we are expanding. We already expanded to cloud, which mostly is about cloud infrastructure tools like Airflow, Dataflow, Dataproc, Apache Beam, and also embedded software engineering. So we develop firmware for IoT devices. And we work with customers all over the world, mostly US, also London or UK, and mostly West European countries. So this is who you are. This is the team of Airflow, the all-time team, because I'll tell you about this a little later, but the team changed over time. So right now we have 6 people, and actually this slide is the most updated slide in the presentation. I already gave the presentation this is the 4th time I'm giving it, and every time I have to adapt it a little bit because we have more people joining our team. So Michał is the last team member that joined. So I'm telling about him first. But Tobias was added the previous presentation when I was working on, and the core team now is like myself, Kamil, Tomek, Karolina, who is here, Kamil, who is here as well. He is an Apache committer. Tobias, Michał, and we had 3 other people working before, and they are still at the company, but working on different projects, mostly GCP related. I put that slide on because it was so cool. I had to put it. We had a rebranding recently, similarly as Airflow. So those 2 match together. This slide is really nice, and I had to put it in. So we started with Airflow in August 2018. 2 people. Right now we have like 6 people working. Now 9 people worked on it all the time, and the people were changing. This is important for later part of the talk. So we had people coming in and out, and we had to deal with that the team is not like focused on Airflow all the time, and we have new people coming all the time. So what we've done during the Airflow development over this year and a little bit, we developed more than 100 operators. That's quite a number, I would say, mostly for GCP, because this is where our focus is, and this is where our customers want us to contribute most. We added those operators for more than 18 GCP services. So King, you mentioned that it's Airflow is well integrated with GCP on Composer, partially because of our work, because we integrated Airflow over the last year with 18 different services. And we also developed something called Uzi to Airflow. Who from you uses Uzi or knows about what Uzi is? Okay, so okay, there's one person. The second, not many. So we hope this number will shrink even further because we have an automated migration from Uzi to Airflow, which is actually cool. Generating DAGs from XML file is, like my friend told me, the world becomes better one XML less at a time. Yeah, that's what we do. One thing what I'm talking today about is like a focus of my work for the last maybe 20 years, more or less, all the time, in different environments. So I worked in telecom environments, in robotics, AI, mobile applications, Airflow, but all the time during my career, I focused on developer productivity. Like this is like something that I liked to do, like to improve my own productivity as a developer, but also improve the team productivity. So there is a kind of journey for me, and Airflow is just last instantiation of this journey to how to improve the life of developers developing for the product I'm working on. And in this case, this is Airflow for a year. And I wrote a blog post. You can read it. This gives a little bit more background of what I'm talking about today. That's a blog post on our page. You can find it on polidea.com blogs. You can find it very easily. Yeah, and it's named the same as today's talk. So we were delivering those GCP operators, but as in this presentation or in this blog post I'm describing, like one of the reasons or one of the main traits I do when I join a project is like when I start the project, I want at the end of the project to be like 10 times more productive as a team so that we deliver things faster, better, and they are better quality. So we not only delivered those operators, but we have also done a lot of more things. So we have now 2 Apache committers, myself and Kamil here. Kamil especially, he's like the documentation wizard, I would say, because Kamil has improved a lot the documentation of Airflow to make it much more accessible for the users and for the developers as well. And that's a fantastic job from Kamil, which continues. And I'll tell about that more, but we are working on new landing page for Airflow to make it more accessible for new users and developers, and on general documentation improvements. I'll talk about that a little bit later. But this is the main part of what I'm talking about. We also developed a development environment for Airflow, which is called Breeze, and I'm super happy with the name. That's my invention. Like it's a breeze to develop Airflow. You see it's a breeze, really. And I'm happy this name caught up, and nobody protested when I proposed it at the dev list. So yes, the whole focus was to improve the development environment, and actually that's something that you might find very useful, because the main idea behind that was that we should make life easier for anyone who wants to contribute to Airflow. A little more about that later. So we to take very active part in migrating from Python 2 to Python 3, as Ash mentioned also. Python 2 is dying, and that's good. We work also on a number of things that improve the general code base quality, like pilot compatibility. I've re-implemented during the Breeze experience or Breeze development, I've re-implemented the whole CI environment, continuous integration environment we run on Travis. And something fantastic that we've done, and there will be few talks soon. One of them, most likely, if we convince our team members, Tomek, to talk about that in Warsaw, we generated, so that's the kind of ultimate way of improving productivity. This more than 100 operators that we developed, that might seem a big number with such a small team. And one of the reasons why it works like that, because we developed a way to generate those operators automatically from Python libraries released by Google, because they are kind of standard. We can get all the documentation parameters, etc., automatically. So all our code that we develop is super high quality because it's generated pretty much most of it. So we have time to do some more interesting stuff than writing operators to interact with one service. So Breeze is the main part of my talk, or main topic for today. And the Breeze came from problems which we noticed at the very beginning when we joined the project, because we had to do a lot of integration tests. We had to run the testing. Airflow has more than 3,000 tests, or close to 4,000 tests right now. They are run on Travis CI, and running all the tests takes a bit long, and you have all these metrics of different environments, different Python version, different databases, and we had to make sure every time we are following really great practices. Every time every PR is there, it has to pass all the tests. And that makes it a bit difficult for somebody who wants to just contribute one change or one operator or few operators, because you need to have a way to reproduce those tests locally if in case they fail on Travis. Because you don't want to wait 30 minutes or 60 minutes or whatever to get the results, especially that most recently we have some limitation in our Travis queues, and sometimes you have to wait 6 hours to see the result of your push, which is not very nice. We are working on that as well to improve that. So what we noticed following the standard documentation, or the original documentation which was there, and the original Docker files and Docker images and scripts, we see that we have many challenges to really run all those tests locally. So first of all, multiple backends, multiple Python versions. There are different executors. There is automated static code analysis that is run also automatically. There we have automated documentation building, and we have, and this all runs on Travis, but you want all of this to run also on your local environment, because first thing that you do when Travis fails, you want to reproduce it locally, fix, and then see that it doesn't fail. That's the usual development cycle you have. And the problems we noticed that were first time when we joined the project was that first of all, it was very long to set up the environment and have it running, because and it was really not easy to find how to do it easily. The frustrations, it took us about like 5 or 6 days initially before we actually ran successfully first few tests with Airflow, and we were confident that we know what we are doing, and that wasn't a short time at all. And the learning curve, how to run the test, how to actually set all the variables properly, how to actually reproduce and repeat the test several times, that wasn't easy. I mean, if you work with Airflow for a long time, you learn how to do it, but it takes you a long time to understand. If you just want to contribute and you don't want it to take you a few days to learn, probably you need something faster than that. That was my feeling when we joined, and especially when we had the vision that our team will grow from those 2 people. So we found out that it's really super important that new team members, when they come, they have a very fast way of joining the project. And the last but not least, there was a really slow iteration speed on the tests. When you tried to run the test several times, and you know, like you thought that you fix and rerun, it took, if you followed the standard documentation and standard scripts that were there, it was really minutes to run one test, like before it actually ran. And then if you wanted to repeat it, it was again minutes, and sometimes even longer, depending on what you wanted to do. And the whole development environment is complicated. This is not something that we can do a lot with, because Airflow has many moving pieces, and there are lots of tests, like lots of components that Airflow talks to during the integration tests. But we can at least hide the complexity and make it very easy to start and manage. So this is This is okay. Something. Okay. Something. Good. So the problem of the original CI environment where the scripts were were designed to only run the full suite of tests, not a single test. It wasn't easy to run a single test. Well, if you knew how to do it, it was easy, but it was difficult to learn how to do it. The original integration test environment was such that all the dependencies were reinstalled every time you entered a Docker container, which wasn't really useful. I mean, if you shut down your machine, you had to wait minutes and many minutes to have it all set up. You entered the environment. If you exited that by accidentally, you had to repeat it again. That was designed very good for CI, but not really good for local development and testing. By default, all the scripts were doing the full database reset, which took like 20-30 seconds. And for the speed of iteration, if you have a test that runs millisecond, waiting 20 seconds every time you run it is not a good idea. So it really literally took, if you followed the standard way, it took minutes to run the tests. And there was no guidance how to quickly iterate. So this fantastic person here, Ash, had a talk hacking on Airflow, which I was watching very closely. So if you are really experienced developer of Airflow, you knew how to hack things to make it faster, and that's what mostly the talk is all about. But then it's a long talk, and you have to figure out how to set up the variables, and I actually learned a number of tricks from that talk from Ash, and I think that was in the middle of my development, and I decided, okay, maybe those tricks you don't have to learn, but maybe they can be implemented, and you can just use it. So the challenge was accepted. The focus was to make the developers more productive. So the idea was like they come, they get the environment, they run, and they can start testing immediately, and it's efficient. Development cycle has to be fast, frustration low. The very important thing, our team, as you saw, was changing and was growing, and we had to make sure that development is shared between the different environments. So we had to figure a way how to update the environment when dependencies change, for example, so that everyone is on the same page and has the same environment. And always in the back of my mind was get somebody who doesn't know anything about, or is a user of Airflow and wants to become contributor. Those guys who disappeared, these are my target. So people who are using Airflow and developing some operators, to make them very easy to contribute the code back. So what were the improvements? There were a few improvements I worked on, and they were mostly captured in Airflow improvement proposals. So first one that Ash also mentioned, there is a multi-staging and multi-layered official Airflow image, which is a base for all the rest. There is simplified development workflow, and this is what Breeze is all about. I'm working right now on migration out of Travis CI to make our life easier and not to wait 6 hours for builds. And in the future, there will be support for system testing for external systems. First two are implemented. The third one is being worked on, and support for system tests is actually also something that our team is working on. So you have several environments to work with testing of Airflow, local virtual environments. You can have your own Travis CI fork. You can have Docker Composer, and this is the part which is exactly what is on Travis CI, and that's where what is right now reflected into this development environment right now. So, by the way, how many of you are using Airflow? I guess pretty much everyone. That's what my guess. How many of you are actually contributing to Airflow? 1, 2. So I hope next time when we give this talk, there will be many more people contributing. So just to show you one thing. So this is the experience. Okay, let me just move it. So this was the experience, the original experience when you when we joined the project to run testing on Airflow. This movie is 20 times speed, so it takes a little bit of time to install everything, run, and at the end, what you get is an error. Actually, I mean, so this is the frustration that we had initially when we joined the project. And so this is how it's not a good idea. Yeah, it takes quite a lot of time to run all of this. Okay, I'll stop this one. Hope I can. So total time of okay, good. So total time of execution of this test was 7 minutes. It was 20 times speed. It was just running one test. It failed, so it didn't run the test. If you actually make it runs, rerunning the test by definition, it took 10 to 20 seconds just to rerun one test. And when you close the environment, it's the same like going back to the 7 minutes. It was 7 minutes you had to wait again. And you didn't have bash history, which is like we are 2019, so you probably want to use some new things which are there. So what is right now? What happened? I implemented Docker images, which are multi-staging and multi-layered, and it means that they are rebuilding only the last part that is needed. So it's very fast to rebuild new images when new dependencies come. We are using cached Docker images, and the test and static test are running this Docker Composer environment, and we are running that on. We can run also Kubernetes tests using Docker in Docker. This is something that we are working on right now. The tests are independent from the CI system that we use, which is prerequisite for migrating out of Travis. But the most important thing that happened after that, I've added some scripts to manage the environment, so you don't have to think about it. You don't have to download the environment, the images. They are just managed for you automatically. So when you enter the environment, okay, you can just specify the Python version, backend, an environment that you want to run, enter the environment, and you have scripts that are using those Docker images, which are actually running all the tests. Yeah. So that was the first step of implementation. What happens is like you could very easily run those tests using a number of bash scripts, which is not very convenient, actually. However, I've also added nice thing, which is like running tests script, which will do a few things. First of all, it works out of the box. So you enter the environment, run the test, and the tests just run. They initialize database only when needed. They set all the environment variables as needed. They have a very low rerun overhead. And actually, they tell you how to use IPDB debugging. You can have some guidance for the user, for the developer, how to actually do some debugging. And you can run it with verbose output. And that was a kind of intermediate step of implementing the whole environment. But what came out at the end is what is named as Breeze. First of all, is just one Swiss Army knife of testing. It's just one script that you can do everything with regarding the testing of Airflow. So, for example, you can run the environment by specifying the backend, the Python version, and it will just run. There are some cool features like, okay, when you rerun it next time, you just specify Breeze, and it will remember what you used last time. That's quite cool. It will automatically manage all the images. So whenever it sees that you need to update your image, it will automatically download and rebuild the images, or will ask you to rebuild the images. We are in 2019, so we have also autocomplete of the options of Breeze. That's something really useful. Again, sub-second test execution overhead. Your sources are directly mounted to the Docker container, so you can edit them outside in your IDE, and they will be immediately changed inside the Docker. And you can have port forwarding, so you can connect with to the database of Airflow, which is inside Docker automatically with any kind of tools you have for database connection. And it has a number of hints for developers. Also, what is really nice, we have running tests. When you run the tests, you can start to use autocomplete because you never remember what is the name of this class or package you want to run. But with the autocomplete, you can actually see and use autocomplete to help you with that. You can keep history across sessions. You can run static code checks within Breeze. So you can just run Breeze, specify the static code checks, and they will run automatically. There is an easy debugging. There is a latest cool feature, which is pre-commit checks. I will tell a little bit about that later. And here is a little bit of a demonstration of how it is to fill Breeze or use Breeze. So sorry. No, I'm not speeding this up. No, sorry. Okay. So first time you run tests, you just enter Breeze, and this is like what happens. You just enter Breeze. Yeah, Breeze. You specify the version of Python. It will run. It will show you some information. I will show you a little bit later about that. And whenever you enter the environment, this movie is not sped up by any means. Yeah, it's just the usual speed. So you can immediately start testing. There is no installation, no time waiting for, and no errors when you enter the environment because it's already pre-built for you. The first time you run it, the database gets initialized and those tests are run. So you can see a few tests are being executed right now. And in a very short while, they will complete. The next time when you iterate on those tests, because presumably they failed, it will just take literally milliseconds of overhead. It will just start testing immediately without reinitializing the database. That was previously when Ash showing how to do that, you had to actually uncomment some line in the code to make this happen, and I had to know that it's happening. Right now, it's all automated, and you don't have to worry about at all. Tests autocomplete. That's again something that you can show. When you really have more than 3,000 tests, you never remember the packages that you want to run. And with autocomplete, you have all these goodies that you normally would expect from modern system recently, and then you can simply run the test that you want to run. So this is working now for all the tests in the code base, and makes it super easy to not having to copy paste code basically, because that's what you usually do. You can also rerun the tests with the database initialization. So if you really need to run the test and reinitialize the database, there is with db-init switch, and it's auto-completable, by the way, as well, that will rerun the whole thing from the scratch and reinitialize the database so that you have a clean state before you run your tests. So those are the things, and there are a few, let's say, goodies or extras that you can see. So there are some hints for developers which are being printed. So you can see, first of all the information about the version that you have, about the version of Python you use, so you know where you are, what you do. There are some commands that you can run manually. There is a way, like description, how you can add Breeze to your path to make your life even easier. There are ports forwarded to the database, so you can connect to it using your IntelliJ or whatever management system you have for database. And you can set up autocomplete automatically as well. And you can, by the way, disable all that information as well, so that you don't see it if you don't need it. Plus, you have some hints like that, again, in order to do testing, everything is explained how you can actually run your tests and do testing with do debugging with IPDB. So these are all the goodies which are there. Okay, let me switch now back to the presentation. Good. Okay, there are some additional resources that you can see. I've recorded intro to Breeze when I show how to get the Breeze up and running in less than 10 minutes. And actually, that was my goal. It's fulfilled. That when you start working with Breeze, you check out the repository, you have a clean Docker environment, and in less than 10 minutes, you have the test running, and it's actually working. For me, I've learned that when I came here, I've learned that in UK, the speeds of internet are not as good as in Poland. Like we have gigabits of internet for like £10 or less. So it's probably less than more than 10 minutes in UK, but in Poland is like, and come to Poland, you know, like we have really good internet there, much faster. It is actually 10 minutes and it's recorded live. There is also the webinar, the webcast or screencast that we've done together with Ash. It's also available about the development environment, about the usual way or the standard way of doing development, and some Breeze information in there, like a lot of Breeze information in there. So we can also watch that. What Breeze features are, first of all, the image management automatically. You don't have to worry about that. There is pre-commit checks, and actually this comment is not valid. We merged almost, no, there is one pre-commit check that is not merged yet, but we have lots of pre-commit checks. I will tell about those pre-commit in a moment. Running test with DB initialization, Travis CI integration. There is quite a good documentation, I hope. It's good. It's written by me developers, so probably it's not as good as it could be. However, we are right now in the process of having technical writer helping that with the documentation. I'll tell about that in a moment. But this is the kind of information that you can expect. So you can, for example, see how to debug your code remotely from IntelliJ if you want. There are some spin-offs from Breeze. So Breeze was actually, for me, also enabler for many different things. These are the pre-commits check. So pre-commits checks, part of them or some of them are using the Docker images, which are managed by Breeze. And they run a lot of static code checks that we have, and more. And Ash recently added a few more. Kaxil added a few more. Ash started using this pre-commit or Breeze recently as well. So we have more and more checks. So we are adding those to make sure our code is good quality and it stays good. So those checks are always also run on the CI, and you have to fix them in order to commit anything. So you will not be able to make a PR without passing those checks. So adding pre-commit for your own development is actually the fastest way to get rid of the problems, because you can run this on your own machine, and it's super easy to install. I used to be afraid of pre-commits check or not to use them because it was always difficult to manage the pre-commit checks between the teams, within the team. But it has changed recently, or a few years ago. We have some frameworks, and one of those is a fantastic framework which is called pre-commit. Well, yeah, how else? This is a Python framework that allows you to manage all the pre-commit checks in single file checked into your repository. It has a very cool command line that you can use, and just pre-commit install. It will install the pre-commits. You can run those pre-commits, all of them. You can run only one of them. You can run it on all files, etc., etc. And by default, it's super fast because it only runs on the files that you are committing, right, or you have in your staging area right now. So it's very fast, including the fact that it's actually run those checks in parallel. As many processors you have, they will run, like if you have many files, it will run in parallel processes to check those files. This is actually super cool. It helps you to catch errors early. So if you commit your code right now, or a lot of people were actually using our Travis to run static checks because it was difficult to set up. Right now with that, you don't have to. You can do it all locally, which means that you don't have to wait 6 hours to see that your space was missing. You can see it immediately when you commit your code, and that's actually super cool. So it also makes our time more efficient because we don't have to point out to the problems that you have with well, like syntax or whatever, because if it doesn't pass, we don't even look at those PRs, yeah? More or less, or we just tell you, just please fix those. And it also promotes good practices. One of the checks there, I'm a long-time shell developer. Actually, Breeze is a glorified shell script, really nothing more than that. But with this shell check, I've learned a lot of things about shell that I didn't learn for like last 20 years, how to do the code properly. So actually, it is promoting very good practices for coding. So right now, when you run pre-commits, you can see this kind of error. So immediately you see the errors and you can fix them. And it has colors, actually, which is good. Okay, what's next? We are migrating out of Travis CI, hopefully soon. We're just waiting for one change in GitLab CI to be released to test it. We have a running Kubernetes cluster on Google Kubernetes Engine, and as it was mentioned there, like about Google contributing to the open source community, they are also helping a lot with Airflow because they have Composer and they care about that. So we have a donation from them with credits that we can run our own Kubernetes engine that we're going to use for this CI, which will make things faster. We are going to have better onboarding documentation, and again, Google helps here because they run this initiative called Google Season of Docs, like Google Summer of Code, but Google Season of Docs, and they are joining together technical writers and open source communities from all over the world. So we have now 2 technical writers assigned to our project, and one of the things which I'm piloting is in improving the onboarding contributor documentation that will come in the next few months. And I'm also working together with Daniel Iberman on this production optimized Docker images, which are based on both Astronomer original image, and I'm bringing that into the whole framework to build it automatically on Docker Hub and have it released as we develop it, as we change the master code. And last thing to announce, we are also running Meetup in Warsaw. That's going to be first Meetup in Warsaw. It's 17th of October on Thursday. This is done together with Google, and we ask anyone who would like to talk and come to Poland and enjoy the speed of internet there. Of course, just apply, and if you have a good talk, we'll be happy to host you there. And that's about it. Thank you. Any questions? So maybe I'll ask a question. Who would like to become a contributor now to the Airflow? Okay, I see a few hands. Good. Anyone? Okay, good. Thank you.
A big mention to the team at Polidea. Like Kamil has helped improving Airflow documentation a lot. Like if you check the documentation of 0.10 and right now, you will be able to appreciate their efforts. So thank you guys. And also Airflow, someone in Apache Con had mentioned that Airflow community was very welcoming. That's why I'm trying to tell you guys to just contribute whatever you can. Even documentation is contributing documentation is helpful. It is also good for your CV and it helps you everywhere. We started with the same way, and yeah. And also special mention to Jarek because Breeze has helped us a lot. Like end users cannot see it, but I have had to wait for 6 hours or 8 hours just because I missed to delete an import statement. So that helps. And thank you all for coming. Thank you all, Nathan. Thank you, Nathan and King, for hosting us, and our sponsors, Astronomer. And yeah, I won't keep you away from your pizza. Thank you.